Alright, here we go. Coming back for another video. Let's do this thing. So this is the semester 1 review. So we're looking at the review chapter that we went through at the beginning of the year. So first you're asked to simplify, so you're just following order of operations, PEMDAS. You want to do what's inside the parentheses first. So I want to take 3 minus 1. And then I can do what's outside the parentheses. So first comes exponents. So I square that 2. And then I can go ahead and do multiplication, right? Number on the outside is multiplication. So we get 8 minus 12, which is negative 4. So there you go for that one. Same thing here, we're simplifying this, and it's not an equation, even though there's an x in it, because there's no equal sign. So we follow order operations. This time I can't add anything inside with that x, so then when it comes multiplication, or exponents, there's no exponents, so then we can distribute that negative 4 to both the x and to the 2. So that is multiplication. And then we can combine like terms. So negative x, 3x minus 4x is negative x. Negative 8 plus 7 is negative 1. Okay, now we're asked to find the product. Product means multiplication. Here we have a 3 terms by 2 terms, so I should get 6 terms, and then I might be able to combine some. So you could do this in a table if you wanted to, and you can multiply 3 rows by 2 rows, so you should get 6 total boxes. Or we can just distribute each one of these. I don't really care how you did it. So we distribute. That's a cubed. That's a 2x squared. That's a positive 4x squared and a positive 8x. And then negative 1 times x is a negative x. Negative 1 times 2 is a negative 2. Okay, so I multiplied all 3 of those by both of those. So now we can just combine like terms. We have a 2x squared and a 4x squared. That would lead us to a 6x squared. We have an 8x and a minus x. That's a 7x. And negative 2 and an x cubed. So there's the product of those two. Asked to factor, so here we can do cab. So because my a is 1, then I can just look at my c and say, okay, what are the factors of 12? What times what is 12 but adds to 7? So that's 3 and 4, so x plus 3 and x plus 4. Okay, then we're asked to factor this next one. So I can do cab on this one as well, but here my a is not 1, so I can look to see if there's a greatest common factor between these 3. There's not. So then I can go ahead and multiply my a times my c and get 24. And because that is positive, that means I'm going to be adding to get to my b. So I'm going to add to get to 11. But since my b is negative, that means they're both just going to be negative. So I'm asking myself, what times what is 24 but adds to 11? Well, that's 8 and 3. But because that b is negative, they're just both going to be negative. Okay, so I take x minus 8 and x minus 3. And then I want to always divide by my a. On the previous one, I could have divided by my a, but my a is 1, so it wasn't going to change the 3 or the 4. When I divide this by my a, I can reduce this fraction. So this is x minus 2. This one I can't reduce, so I go ahead and take that 4 and put it in front of the x in the parentheses. So 4x minus 3. If it can go into both of them, that means you probably could have divided out a greatest common factor to begin with. You should always at least check the first times the first, so x times 4x is a 4x squared, even though it's a y, so I guess I should change these to a y. We're so used to doing x all the time that I always put an x, but whatever. So those are my 2 factors, and you can check to make sure. Alright, so chapter 1, we're solving. So here we simplify, and then we go ahead and get x on one side and solve. So can't do anything in the inside, there's no exponents. So then I go to multiplication, so I distribute 3. We get 6x minus 12. I'm not distributing the 7 because the 7 is in front of that negative, so I'm going to distribute that negative to both of them. So negative x and a negative 5. Then I can combine like terms there. 5 minus 7 is 2, so I have 2 minus x. And 6x minus 12. So I could add 12 and add x on both sides. So then I get 7x equals 14. So 7x equals 14. Divide by 7, divide by 7, get x equals 2. You could always plug that back in and check it. 2 times 2 is 4, 4 minus 4 is 0, 0 times anything is 0. 2 plus 5 is 7, 7 minus 7 is 0, 0 does equal 0, that's a true statement. So x equals 2 is correct. Alright, so number 2 here, the word problems that you guys hate. So let's try to figure it out. Okay, so you're adding so many gallons of pure alcohol mixed with 20 gallons of 15% alcohol. Okay, so I'm taking so many gallons in one bucket, and I'm adding another 20 gallons. So if I add X amount of gallons and 20 gallons, how many gallons do I have? Well, that means I have X plus 20 gallons, right? And big, huge jar. Now, of that X many gallons, I want it to be pure, so that would be 100% of this. So that's 1. If I move my decimal over 2, that's just 1. And then of the 20 gallons, I want a 15% solution, so that's 0.15. And then of this mixture, I want a 25% solution. Okay, so I change these percentages into decimals. So 1 times 25, or let's switch it. Let's do it this way. X times 1, because that's 100%, plus 20 times 0.15, because that's 15, equals 0.25 times x plus 20. Okay, so there's our equation all written out. So now I can start doing the math here. I can take x times 1, which is x, 20 times 0.15, which I think is like 5 or 3 or something like that. Can't remember. I'll do it though real quick. 0.25 times x, distribute this to both of them, and then 25% of 20 is 5. That's 5. So if that's 5, this must be probably 3. Yeah, so that's right. Okay, so now I can solve this. I can subtract 3. On this side, I'm going to subtract 0.25. So it's like minus a quarter, right? So 1x minus a quarter x is 0.75x, 75 cents, right? And then we get 2 here, so we divide by 0.75, divide by 0.75. We get x is equal to 2 2/3, so 2.67. So there's our answer, and again, I can plug it in, make sure it works. Just like you guys, I'm too lazy to plug it in. Or at least most of us are pretty lazy. Okay, anyways. Alright, so Callie went on a 20-minute trip to drive her boat upstream to the water. She took her boat upstream to the water ski. It took her 20 minutes to water ski. It took her 20 minutes to her favorite spot. And then coming back, she went the same boat speed, but it took her 15 minutes, only 15 minutes. That's also because the current in that river was 5 kilometers per hour. So what is her boat speed? So her speed was the same both ways. So we're after her speed here. So her speed on the way there, and speed is equal to distance over time. So her speed on the way there, we don't know, but we know her time is 20 minutes. We don't know the distance. That's okay. And then on the way back, her speed is, overall she gets there faster because her speed of the boat is the same as the first on the way there, but we have to add that 5 kilometers per hour that she went faster. So s plus 5, and her distance, we don't know yet, equals our time. This time our time was 15 minutes, right? Because that added 5 miles, or 5 kilometers per mile, or 5 kilometers per hour, sorry. Okay, but we do know that she travels upstream a certain amount, and she stops, right? And then she travels back. She leaves from the same spot and comes back to that exact same spot. So we know her distance is actually the same. So if we set these equations equal to d, then we know distance over time. Why did I put distance times time? I don't know. Well, so we need to fix that. So divided by 20, so that means I multiply by 20, so the distance equals 20s. This one, flip that around, divided by 15 here. So we times by 15. And this is actually 15 minutes. And this is actually 5 kilometers per hour. So I need to convert one of those. So I need to either convert this to hours, or I need to convert this to minutes. So if you don't want fractions, then you convert 5 kilometers per hour, so just times that by 60, and because there's 60 minutes in 1 hour. So you can convert this, switch this to 5 times 60, so 5 times 60, that's 300, so 300 minutes. Now we can distribute that 15, so 15s, and then 300 times 15 is 4,500. Equals d, and our distance is the same, so this d is equal to 20s, and this d is equal to 15s plus 4,500, so we can set those equal to each other. 15s plus 4,500. Subtract 15s on both sides. So we get 5s equals 4,500. Divide by 5, we get s equals 900. So that's 900 minutes, right? Her speed is 900 kilometers per minute. So if we divide that by 60, so 900 divided by 60, we get 15. So her speed equals 15 kilometers per hour instead of per minute. Okay, going forward, simplifying these expressions, we can't take a square root of a negative, so we switch that to I, because I is equal to the square root of -1. So this becomes I square root positive 25 now, and square root of 25 is plus or minus, so plus or minus 5i. And then we're just adding here. Look at that symbol. Make sure you look at the symbol in between the parentheses. Just because there's 2 sets of parentheses doesn't mean it's multiplication. This is adding, so we just combine like terms. 3 plus 9 is 12. 2i minus 3i plus a minus 3i is just a negative I. Here we're multiplying because there's nothing in between the parentheses, so then we can go ahead and distribute this and multiply, and so we get negative 8 plus 4i. 3i times 4 is a 12i. And then we get 3i times a negative 2i, that's a negative 6i squared. Don't forget I times I is I squared, just like x times x is x squared. But I squared, just like I is equal to square root of -1, I squared is equal to -1. So that'd be negative 6 times -1. Not negative 6 minus 1, negative 6 times, because it's negative 6 times I squared. So that becomes a positive 6. So then we get a positive 6 here. And we can add it to negative 8, so we get negative 2, and then plus 16i. So there would be my answer there. Okay, when I'm dividing complex numbers, I want to multiply by the conjugate of the denominators on top and on bottom. So that's 1 minus 2i, because the conjugate is, first term's the same, so 1 and 1, but the second term is opposite, so that's positive 2i and a negative 2i. Now we can multiply it just like we did on C. So we can multiply the top and multiply the bottom. When we multiply the bottom, when we take a 1 times negative 2i and a 1 times 2i, those are going to cancel out, right? So then all we have to do is just first times first, which is 1, and last times last, which is a negative 4i squared. And the I squared is just -1. -1 times -4 is a positive 4. So we get 1 plus 4, and 1 plus 4 is 5. So we get 5 on bottom. On top, we're going to have to FOIL it out, multiply it out. 6 times 1 is 6. 6 times 1 is 6. 6 times negative 2i is negative 12i. 2i times 1 is a 2i. So we get a negative 10i there. And then 2i times a negative 2i is a negative 4i squared. So that I squared is going to be negative 1. Negative 1 times 4 is positive 4. So 6 plus 4 is 10. So we get 10 minus 10i. So this is 10 minus 10i on top. So you can simplify that and divide everything by 5. And so we get 2 minus 2i. So we know I is equal to I to the first. I to the second we know is equal to negative 1. And I to the third is equal to just a negative I. And then I to the fourth is equal to 1. I to the fifth will be back to I to the first. So these just repeat in a pattern of 4. So you can do several different things. You could create a chart. This is 1, this is I, this is negative 1, this is negative I, and then every rotation. So this would be raised to the first power, raised to the second power, raised to the third power, raised to the fourth power, and you could keep going around until you get to 17. That's one way to do it. Another way is just do remainder, because it goes in a pattern of 4. Then I can just take 17 and divide it by 4. See how many times it goes into evenly. So it goes in evenly 4 times, so that would mean it would make full 4 rotations. And then a remainder is 1, so that goes an extra 1. So my answer to this is just I. Another way you can do it is just use I squared. So I squared we know is negative 1. So I squared, if I raise that to the 8th, that would get me 16, I to the 16. So if I multiply that by another I, that would be I to the 17th. And so I squared is negative 1. Negative 1 raised itself 8 times is 1. And then 1 times I is just I. So there's another third way to do it. So however you want to do it. Okay, solving quadratic. So there's 2 ways that you can solve. Well, maybe there's a few more ways. If you're missing your b, then you can solve by square roots. But here we do have a b. It's 2. So you can try to factor this, or you can use quadratic form. Remember, you can use quadratic formula on any of these problems, any quadratics, because it'll solve any quadratic, because it's the quadratic formula. You could actually do completing the square too, but your a has to be 1, so you'd have to divide everything by 5, which is not fun. So we can try to cab this real quick, factor it. So negative 20, and because that's negative, we're going to subtract to get to 2. So what times what is 20 but subtracts to get to 2? So we have 4 and 5, and we have 10 and 2, and 20 and 1. So that's not going to work. That's not going to give me 2. So I have to use quadratic formula here, because it's not factorable. So that means my answer is either going to be irrational with a square root, or it's going to be imaginary. So quadratic formula, negative b plus or minus square root b squared minus 4ac all over 2 times a. So remember, when you're doing this, you have opposite of b, so that'd be negative 2, plus or minus, so that is 2. There's 2 answers here. Square root of b squared. Whenever you square your b, even if it's negative, you're still going to get a positive. So that's 4 minus 4 times my a, which is 5, times my c, which is negative 4. I always start on the inside, and then 2 times my a. So I start with this negative 4 times 5 times negative 4. So that's negative 20 times negative 4, which is a positive 80. All over 10. And then I can simplify that. That's 84, right? Let's come down here. X equals negative 2 plus or minus square root of 84. So I don't know there's no perfect square of 84. So we have to simplify that radical. So we can break down this radical into 4 times 21. And the square root of 4 I know, so that's 2. So we get negative 2 plus or minus 2 square root 21. Because 21 I can break down to 7 and 3, but there's no pairs there, right? Don't know the square roots of those. Okay, and then it's all over 10. Now because all 3 of these have a 2 in it, this negative 2, this positive 2 in front of the square root, and the 10 on bottom, we can factor out a 2 out at the top. So I'll do this one at a time. And you can factor out a negative too if you really wanted to. That plus or minus would still be in there, plus or minus. And then so negative 1 plus or minus square root 21 all over 10. Now this 10 and 2 can cancel. And so you get negative 1 plus or minus square root 21 over 5. Never try to cancel what's on the bottom with inside the square root, because that's actually not 21 underneath there, right? That's more like the square root of 21 is 4 point something, so I can't cancel anything inside the square root with anything on the outside. And you can't cancel, say if this 2 in front of the 21 wasn't there to begin with, I can't cancel the negative 2 and the 10. You have to cancel on every term, the 2 on the top and the 1 on the bottom there. So here's your final answer. It's irrational. Alright, find the lengths of the sides of a rectangle, consecutive integers. Find these lengths. So consecutive integers, that means like 1, 2, 3, right? Right in a row, right after one another. So on a right triangle, we know something, that a squared plus b squared equals c squared, right? So I'm looking for 3 numbers that when I square them, the 2 smaller ones add together to equal the third one squared. Right, so the famous ones of this is a 3, 4, 5 triangle. So I can take 3 squared plus 4 squared, so that's 9 plus 16, and that equals 5 squared. So my sides of this would be 3, 4, 5. Those are my sides of this right triangle. Those are consecutive, they're one after another, and they fit Pythagorean theorem. Okay, solving rational equations. So there's a few ways that you can do this. One way is to combine this fraction first on the left, or if you have another fraction you want to combine you can combine your fractions into one, and then you have a proportion. So whenever you have a proportion, right, you can just cross multiply to get rid of dividing by d. You multiply d on both sides, right? So I just take a times d and c times b, and then I can go ahead and solve that. So I could combine that, that's one way, into the proportion. Or I can look at all my factors of the denominator here. And so I could factor this one to the right as if x plus 1. And then I can take all my factors and find my, like the greatest common denominator, and then multiply every term by that greatest common denominator. So here's one factor, x plus 1. Well, I have that over here, so I don't need to repeat it, right? So my least common multiple would be, or greatest common denominator, whatever you want to say, is x plus 1. There's one of them, okay? And then they both have this x, so I don't need to repeat that. So there's my least common multiple, or greatest common factor, or greatest common denominator. So I can multiply every term by this LCM, and it'll get rid of this denominator, okay? So we have 4x plus 3 over x plus 1, and I'm going to multiply that by this LCM. So these x's cancel out, right? Now my denominator's gone on that term. And then on the next one, I'm going to multiply that by the LCM. So I have to multiply each term. Alright, so here the x's would cancel out, so that denominator is now gone. And then finally, the right side of the equation. Now this, we factor that, right? That factors 2x times x plus 1, so the whole thing is going to cancel. Right? So then we just have this equation, x times 4x plus 3, which is a 4x squared plus 3x, plus 2 times x plus 1, so that's a 2x plus 2. And over here we just have 1 times 1, which is 1. So then we can combine like terms, and we get 4x squared plus 5x plus 2 equals 1. We can subtract 1 on both sides, because now we have a quadratic, and in order to solve a quadratic we need to either factor. So I'm going to subtract 1 on both sides, subtract 1, so we get 1, because now it's set equals 0, so now we could use quadratic formula, or completing the square, which we don't want to do because we have to divide everything by 2, or we can try to factor it. Oh, that's plus 1. So I'm going to factor this because the factors of 4 that add up to 5 are 4 and 1. So x plus 4 and x plus 1. But then I have to divide by my a. What's nice about solving is when I divide by my a, I can just leave it as a fraction, and then I just take the opposites, right? So here, what plus 4 over 4 is 0 is negative 4 over 4, which is just negative 1. And then what plus 1/4 is 0? Well, that's a negative 1/4. So those are my answers. So that's one way to do it. Or you could combine this to beginning. You could combine those two to begin with, right, and create one fraction. The greatest common denominator you would have to find between those two, which is the same as this LCM overall. So, right, because x, here's my factor x, and here's my other factor x plus 1. So the greatest common denominator of just those two is x plus 1 times x. Okay, so number 8, you're solving a radical equation. Solve radicals, we want to get the radical by itself. So if there's something being multiplied in front of this, we need to divide it, right? If something's being added to this radical, then we need to be subtracting it. Okay, so we're going to try to get the radical by itself first, which it is. So once the radical is by itself, then we can go ahead and get rid of the radical. So to get rid of a square root, I'm going to square that side, so that means I have to square this side. Okay, but when you square that, you introduce some extra solutions because you're squaring it, and I'm going to square that x. That means originally I only had one answer. Now I'm going to have multiple answers, so I got to check to make sure those actually work. And actually, that's what I should have did from before, is check to make sure negative 1 works. And negative 1/4 worked on the last one, which negative 1/4 is fine. That works in all of them, but negative 1 doesn't, because when I plug negative 1 in, so check x equals, check both of them, but x equals negative 1 does not work right here, because negative 1 plus 1 would be 0, so that one does not work. So that one doesn't work. Okay, back to this one. So I square this, so I get 9x squared plus 1530x plus 25. So I added an extra answer in here, so I need to check to make sure I'm right. Then I can set it equal to 0 because I have a quadratic, right? Sometimes it's nice the quadratic will cancel out, but this one doesn't. Minus 7 as well. So then we have this equation, 0 equals 9x squared plus 27x plus 18. Okay, and then we can see we can factor out a 3. Right? So we take out a greatest common factor, which is a 3. And then 0 divided by 3 is still 0, so we can go ahead and take that 3 all the way out and get 3x squared plus 9x plus 6. And so here, we can take out, I guess, we could take out 9, right? So we can take out another 3. So this 3 is gone, this turns into a 3, and this turns into a 2. And then we can see if we can factor or use quadratic formula. Here, we get factors of 2 that add up to 3. That would be 2 and 1. So x plus 2 and x plus 1. Now we don't have to divide those by our a because we no longer have an a. So it's x minus 2. And x equals minus 2 and x equals negative 1. Again, I need to check those. So we check. And so negative 2 times 3 is negative 6. Negative 6 plus 7 is 1. Square root of 1 is just 1. And negative 2 times, square root of 1 is plus or minus 1. Right? And then when I plug in the negative 2 times 3 is negative 6. Negative 6 plus 2 is negative 1. Right? So that can be right. If I plug in a negative 1, I get negative 3. That's 4. Square root of 4 is plus or minus 2. And then when I plug in negative 1, I get negative 3, and we get 2. So that is right as well. So we'll go with both of these. Okay, solving the inequality. So you can treat the inequality just like an equal sign, and then you can just test your answer on a number line and see if it's true or not. So distribute, we get 3x plus 15 plus 1 is greater than or equal to 5 plus 3x. So here, notice that we have a 3x on both sides, so that's actually going to cancel out when I subtract them. So I get 16 is greater than 5. So is that a true statement? That is a true statement. So actually any x on this problem will actually work. So this is actually our solutions right in interval notation. So write your answers in interval notation because multiple answers can work, and in this problem every x will actually work. Right? We can test it. Plug in a 1. 1 plus 5 is 6. 6 times 3 is 18. 18 plus 1 is 19. 1 times 3 is 3. 3 plus 5 is 8. Is 19 greater than or equal to 8? Yes, it is. You can try a negative 1. That'd be 4. That'd be 12. That'd be 13. That'd be negative 3. That'd be 2. Yep. So it's going to work for all numbers. Solve this inequality. So this is a quadratic. So we want to set it equal to 0. Not really equal to 0, but less than or equal to 0. So plus x minus 4 is less than or equal to 0. Here, don't care about the equal sign. We'll deal with that later. Or inequality, we'll deal with that as an equal sign for now. And then we'll come back and just test our answers to make sure it makes the statement true or not. So this is this factorable. We have negative 12. So what times what is 12 but subtracts to 1? So that's 4 and 3. So that's a negative 4 and negative 3. So those are my factors. So that means my solutions would be, or my factors are x plus 4 and x minus 3, but I need to divide by my a, which is 3. So my solutions would be x equals negative 4/3 and x equals positive 1. So we can plug those back in and see if it makes the statement true. Right, so we have 1, that'd be 3, 4. 4 is equal to 4, right? Plug negative 4/3 in. Negative 4/3 squared, that'd be 16 over 9. So 16 over 9 times 3. 3 would cancel with this, so we get 3 on bottom. We get 16 over 3. 16 over 3 plus negative 4/3. So that'd be 12 over 3, which is 4, and 4 is less than or equal to 4. So both of those work. But you really don't have to check those ones. What you do, though, is you put them on a number line. So it's negative 4/3 and 1. But since they work, that means we would have solid dots here. Okay? Because it would be included. That's the or equal to part. Okay, and then I want to test numbers in between. Actually, I can test to the left and the middle and to the right. But really, if I just test in the middle, and if it's true, that means it's everything in between those two numbers, including those two numbers, since it's or equal to. If it's false, then it's everything going on the outside of those numbers, but including those numbers because it's or equal to. So I'm just going to test a number in between. So I test 0. Plug 0 in is 0 plus 0. 0 is 0 less than or equal to 4. Yes, that's true. So that is true. So since that's true, that means it's everything in between those two numbers, and because we're or equal to, that means they're included. So there is our answer right there. So there you go for that chapter. We can move on, or anything. Yeah, I think we're at the end of that chapter. Nope, we are not at the end of that chapter, because now we have absolute value inequalities. Okay, so here we have 2, and we can treat this as an equal sign and then come back and test it just like we did the last one on a number line. So we can treat this as an equal sign. So really we have 2 equations. Absolute value has 2 equations. Now you can do 2 different things. You write the first one, okay, but the second one you can either change the number on the right, or you can change both of these on the inside, okay, and then you don't have to do anything on the right. So if you want to leave the inequality in there, you can, okay. Oops. If I want to leave the inequality in there, I can. Alright, but then if I change this right side, that means I need to flip that inequality, because basically I'm multiplying it by negative 1. So then it would be something like this, negative 3, but I flip that sign. If you change the absolute value part, then you can keep that inequality the same. Okay, or you can treat them both as an equal sign. That's fine as well, and then you can just test your numbers. As long as I play by the right rules, I can keep that inequality symbol in there, and that will tell me my answer as well. So it's however you want to do it. So both equations or inequalities, you're going to subtract 5 unless you switch the absolute value part on the second one. So we have 2x is less than -2, and here we have 2x is greater than -8. Divide by 2, divide by 2, divide by 2, divide by 2. So we get x is less than. Remember, whenever you multiply or divide by a negative, you flip that inequality. Okay. So we're good here. So we get -1, and we get x is greater than -4. Okay, so here it tells your answer. All our x's are less than -1. So if I'm on a number line, I'm at -1. All our answers are less than -1. But this says all our answers are greater than -4. So at -4, just down here, -4, all our answers are greater than -4, so all our answers go this way. So what's probably going to happen is our answers are actually just going to be the ones in between these two. And we can actually go ahead and check that. So we put on a number line -4, -1, and we test a point in between. We can test point, actually, all three if you want to, but you can test point in between. If it's true, then it's everything in between. If it's false, then it's everything on the outside. Sometimes the only thing you got to worry about this is if the absolute value is always true, right? So usually it happens if the absolute value is greater than some negative number, right? Because that's always going to be true. So most cases I just test a number in between, but you can test on the left and the right, and that will tell you if it's always true, right? If it's true on all three of these, then it would be true for everything. So -2. So I plug in -2. 2 minus 2 is -4. -4 plus 5 is 1. Is absolute value 1 is 1. Is 1 less than 3? 1 is less than 3, so that's true. So it's everything in between. So from -4 to -1, it's true. And here I'm going to use parentheses because it's just less than. So because it's less than and not or equal to, it's just parentheses. So that's our answer. So from -4 to -1, all the answers in between there. Okay, solving absolute value equation again. So on this, we want to get absolute value by itself. So the last one was already by itself. So since something's being subtracted from the absolute value, you want to go ahead and add 2 to both sides first. And if something's being multiplied, then you want to divide. Right, so we want to get the absolute value by itself first. Oops, there we go. Equals +1 now. Okay, so now that's by itself. Now you can write your two equations, right? 4x plus 3 equals 1. Okay, and so I can write my second equation. I could change the absolute value part if I wanted to for my second equation, and then leave the right side alone. You can just change one side. It doesn't matter which side. Usually we change the one on the right because sometimes it just has one, but it might have more than one term on the right. So there you got to be careful. Make sure you take the opposite of both terms. Okay, so here we would subtract 3. So I get 4x equals -2 divided by 4. We get 1/2. So x equals -1/2. And since we have an equal sign, we just want to check our answer. Right, so -1/2, plug it in. That'd be -2. -2 plus 3 is 1. Absolute value of 1 is 1. 1 minus 2 is -1. -1 does equal -1, so that's true. Okay, then this equation, we add 3 on this one, because I did the opposite of the absolute value. To get -4x equals 4, divided by -4, divided by -4. We get x is equal to -1. So test that out. -1 times 4 is -4. -4 plus 3 is -1. Absolute value of -1 is 1. 1 minus 2 is -1, so that's also true. So those are our answers. X equals -1/2. X equals -1. Okay, now we're into the next chapter. So find the distance between 2 points and then find the midpoint. So distance formula between 2 points is the square root of your x1 minus x2. You could switch those, doesn't matter. Quantity squared plus difference of your y. So if I started with x1, that means I need to start with y1 minus y2. That's squared. So I have to take the difference of the x's, difference of the y, square them, then add them together, then take the square root. So you got to go in that order, right? So If I put this x first, that means I have to put this y first. Okay? And then I'm subtracting the second x, which is a -1, and I'm subtracting negative, that means I'm adding. So I get 3 here. And I'm subtracting my second y, which is a -y. So that's going to be adding, so we get 8. Now I'm going to square those. Okay, so then I get 9 and I get 64, and then I'm going to add that. So I get 73, and then I'm going to square root that answer. Okay, and this one can't break down, so you can leave a square root. 73 is fine. So make sure you don't remember to square root. Okay, take the difference. Remember, when you're always subtracting. So if you're subtracting negative, you got to be adding. Okay, you could also put these on you could graph these and then do rise over run, right? And then go ahead and just add those, how much it rises and how much it runs, square those and then square root it after you add them. Or you could do Pythagorean theorem. This is how we get the distance form, as Pythagorean theorem, right? So if I find this distance, how much I'm going up, my rise, and then my run, and I use Pythagorean theorem, this would be the distance here. This would be your d. So you could use Pythagorean theorem. So there's the distance. Let's put d equals. Okay, now my midpoint formula is I'm actually going to find the average between my x's. So that means I'm adding my x's, and it's a point. So 2 plus -1 divided by 2, so that's the average. So that's my x. And then I'm going to take and add my y's. So that's 3. So we'll add these, 3 plus -5 over 2, because I'm finding the average, the middle, the midpoint. So that's divided by 2. So that's 1/2. And that's -1s, because 3 plus a -5. 3 plus a -5 is -2. -2 divided by 2 is -1. So there's your midpoint. There's your distance. Find the center and radius of the given circle. So remember, basically kind of what makes this 0, that'd be a -3. What makes this 0, +4. So your x is equal to -3, and your y is equal to 4. So your center is -3, 4. And then your radius, you just square root this, so 6. So r equals 6. So I'm going to go to -3, 1, 2, 3, 4. 1, 2, 3, 4. So -3, 4 right there. And then I'm going to go my radius of 6. So that means I'm going to go up 6. 1, 2, 3, 4, 5, 6. Right 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then this needs to be up for 1, 2, 3, 4. So that's 4. 1, 2, 3, 4, 5, 6. So there's my beautiful circle. My center, -3, 4. My radius equals 6. Okay, now write the equation. So we're kind of doing this backwards. So my center was -3, but in the equation was +3. So my x is -1. So that means my factor would be x plus 1. And it's being squared. And then -7, so that means it's a y plus 7. Quantity squared. And then we're adding in between. So there needs to be a plus sign in between. Equals our radius, where our radius is 4, but I need to square that, so I get 16. So there's my equation for that one. What's the difference between a relation and function? A function, for every x, there's only one y. So the relation is different. So a relation is just how can one x turn into a y, basically. How are they related? Like y equals x. That's a relation, right? Every function is a relation. So every function is a relation, but not every relation is a function. So the difference between them is a function has to be for every x there exists only one y. So for every So for every x there exists only one y. So like x squared is fine, y equals x squared is fine. X is related to y by taking x and squaring it, you get y. So that's a relation, but it's also a function because I can put any x in here and only get one answer out. Okay. Now, so I can plug in -2 and get 4 out, right? So that's fine. I have one x and I have one y, okay? But when I plug in 2, I get 4 out, and that's okay because I have a different x even though I get the same y. So for every x there exists one y. So that means for every x there's only one y. That means I don't get two answers out. So it's okay to have two different x's in the same answer, but I can't have something like this, the square root of x. Because the square root of 4, if my x is 4, I literally get two answers out, +2 and -2. So for every x, for one x, I can only have one y. But it's okay to have two different x's with the same y. Hopefully that works and you understand it. Okay, so that's the difference between relation and function. So every relation is a function, but not every function is a relation. All right, identify the order of pairs as a function. So that means if I have no repeated x's, then I'm fine. Okay, but here I have an x that repeats, so I need to have two different, the same y value. Okay, so this 2 has a 3 and this 2 has a 7, so this is not a function. It's a relation, but it's not a function. Okay, not a function. 1x, 2 y's. Okay, so that doesn't work. Okay, so be able to use the vertical line test so we could graph those and see, does it pass the vertical line test, like y equals x squared. Right, that looks like this. This passes the vertical line test. The square root of x looks like this. It does not pass the vertical line test. So this passes. So it is a function. This does not pass. This is a fail. So not a function, right? Function, not a function. Even though a lot of times I'll still call this a function, right? Even though technically it's not a function. Okay, so stating the domain and the range. Domain is the x's. Domain is the x's. So here, if I look at this graph, oh, this must be B. Alright, so here's A. The domain is my x's. So that'd be 2, and you can just list them as a set. So 2, -2, -1, -2, come on, -2, -1, and 5. And my range would be my y values. So that'd be 3, 5, 9, and 7. So I just list them as a set if it's like that, where I have a list of ordered pairs there. B is this equation, right? And so we'll say this continues on. So my x's start right here. I'm going to go set that's -5. And since it doesn't really quite touch -5, then I can do a parenthesis, right? But if it touched -5 as my x, then I can do a bracket. But we'll say it doesn't quite touch -5. So that's a parenthesis, and then it goes to the right. So we always do domain from left to right. So I look, what's the farthest left value that it touches or gets close to? So it gets close to -5, and then I go to the right, and it keeps going to the right. These arrows tell me that. So it goes to infinity. So there's my domain, and my range is my lowest. To my highest y value. So my lowest y value, well, even though this arrow goes to the right, it's also going down as well. Okay. So my lowest y value is actually -infinity. And then this arrow up here keeps going up as well. It just goes really, really slow upwards because it's a square root function. And so that it's from infinity. Negative infinity to positive infinity is my range. Here I'm finding f of x plus 2, so that means I'm taking x plus 2 and plugging it into these two spots. So negative parentheses x plus 2, because that's my x, and I'm going to square that, and I'm going to take 2, and I'm going to times it by x plus 2. X plus 2, subtract 3. So I'm going to square this first, and then I'll distribute the negative. Then I can distribute the 2, and then I can subtract 3 at the end. So this is x squared plus 4x plus 4. Don't try to shortcut. Then I can distribute that negative. So that's negative x squared minus 4x minus 4. I can distribute this 2 as well. So that's a 2x plus 4 minus 3. Okay? So now we can combine like terms here. These 4's will cancel, right? This x's will simplify, so we get negative x squared minus 2x minus 3. So there's my answer. That is f of x plus 2. So that's what it equals. Increasing and increasing and decreasing. And we'll go ahead and say there's arrows on these as well. Increasing and decreasing is the domain. And my domain is from negative infinity to positive infinity. So we'll say there's arrows on that. Okay, so my increasing, decreasing, and constant is all about my domain. Okay, it's where on the x's of my graph increasing. So draw your graph from left to right. I'm drawing it up, so that means it's increasing up until this x value right here at -1. So at -1, it stops increasing. So from negative infinity, from left to right, negative infinity up until -1, it is increasing. Okay, and I should probably say INC for increasing. And then I keep on drawing it, and now I'm drawing it down from left to right up until this value of +1. So it is decreasing because I'm drawing it down from -1 to +1. And then I start drawing it up again, and it just keeps going and keeps going and keeps going. So then it's back to increasing, so I join that together from 1 to infinity, and that covers my domain, right? Negative infinity to -1, -1 to 1, 1 to infinity, that covers my whole domain. So that's where it's increasing and decreasing. And it covers the domain, and it goes from left to right. And don't care about the y values. Just where on the x's. Is it going up? Is it going down? Does it remain the same? Okay, write the equation of slope-intercept form in slope-intercept form, so that's y equals mx plus b. So I need a slope. M is the difference of your y's over the difference of your x's. So whatever y I start with, say -4, that means on bottom I have to start with -1. And I'm subtracting those, so I'm subtracting 3, here I'm subtracting 2, and this is getting my slope. So -7 over -3, negative over negative is positive, so 7 over 3 is my slope. Now I can write y-intercept form. I could put it in point slope form first, and then convert it to y equals mx plus b. So that's y minus my y value. I can choose any point I want to. My slope times x minus my x value. So I can do y minus 3. If I do -3, that means when I come over here for my x, I do -2. Now if it was the -1, you could write it y plus 4, because it's the opposite. My slope, that's a 3. X plus 1, because I'm subtracting my y value and subtracting my x value, so that's taken opposite. Both of these equations will be the same. Okay, so then we can distribute the 7/3, so we get 7/3 x minus 14/3, okay, equals y minus 3. We can add 3. So adding 3, I need a common denominator here. So 7/3 x minus 14 14/3 plus 9 over 3. So that's -5. So y equals 7/3 x minus 5, 5/3. So there's my answer. Okay. You'd get the same answer here on this one as well. It would just simplify to it. So it doesn't matter what point you use. Okay. So now write an equation in standard form. Okay. So now we're doing standard form. So that is ax plus by equals c. And here a can't have any fractions, and a has to be positive, and then x and y are on the same side. Okay, so we do the same thing for our slope. Our y, subtract our y's over subtracting our x's. Make sure you start with the same point. So we get -3 over -3, which is good, because then that simplifies to just 1. So our slope is 1, so then we can put it in point slope form. Whichever point you want to use, doesn't matter. My slope is 1. Okay, so this is number 11. So it's number 10. Maybe I should raise that. I don't know. Draw line for this. Okay. Alright. Y minus 4 equals x minus 2. Distribute the 1, we get x minus 2. Add 4. Well, yeah, add 4. Well, we want our x's and y's on the same side. We don't have any fractions, so we don't have to multiply by anything to get rid of the fraction. So we just need our x's and y's on the same side. So if I subtract x over, that's fine, but I'd have a negative x. But I want a positive a, so I need a positive x, so I might as well just leave x on this side and move the y over. So then I have minus 4 equals x minus y minus 2, so then add 2 over. So then we have x minus y equals -2. And so there's my answer. And you could rewrite it where it looks like ax plus. So you could rewrite it and it would look like this. X minus y equals -2. So you write it like that, same thing. Alright, parallel to, so here we're going through a point, 1, 3, and it's parallel to this equation. So what we're going to do is we're going to find the slope of this, y equals 3x plus 2, which is 3. And we want a parallel, so parallel means I keep the slope the same. And now I'm going through this point, so I use this slope from this equation, and I use this point. And then I put it in point slope form. So my slope is 3. And then I go ahead and distribute that. Add 3 and 3, so we get y equals 3x. So there's my equation that has the same slope, but it goes through that point 1, 3. Oh, in standard form. Oh, sorry. So I need to go ahead and subtract that y. So I want it in standard form. So we get 3x minus y equals 0. Okay, same thing on this, but it's perpendicular. So I want to find this slope, which is 4. And I want to take the slope that's perpendicular. So that's opposite, change the sign, and flip the fraction. Okay, so -1/4, that's what I'm going to use. I'm going to put it in slope-intercept form. Or not slope, point slope form, sorry. -1/4 x minus my x value, which is -3, so that becomes a +3. Distribute that. And we want this in standard form, so we want to get rid of these fractions. So I could distribute this if I wanted to, but I don't really need to right at the beginning. That's an x. What I can do is just multiply everything by 4, because that's my denominator here on my slope. So if I multiply both sides by 4 of my equation, then it will get rid of that denominator, and then I don't have any fractions, because I can't have fractions in standard form. So if I multiply everything by 4, this would be a 4y minus 16. So I'm multiplying this by 4, I'm multiplying this by 4. I could have done it at the beginning, and then I just have to, they would cancel, and then I wouldn't have to distribute anything. I would just have a -1, I guess, to distribute. So this becomes -x, this becomes -3. Now I can go ahead and put my x's and y's on the same side. So I get x plus 4y equals 13. It looks like it'd be 13. Okay. Intervals. Oh, where's our graph continuous at? So here, because we have a jump here, so basically I'm kind of like writing my domain. So it goes from, ooh, I can't even tell that. -1. So where's this discontinuous at? It's right here at 2. So at 2, x is discontinuous. So let's go ahead and say there's arrows here. That will help. Okay. So from negative infinity, because my graph goes from left to right, so draw it from left to right. So I keep drawing it. So I can keep drawing it until here I have to pick up my pin. So at 2 I have to pick up my pin, so it goes to 2. Okay. So it does go to 2, and I actually do have a y value at 2, so I go ahead and put that in a bracket. And then I continue on from there. And then since this is an open circle here, I'm going to use a parenthesis, and I go from 2 to infinity. Okay, so right here, that would kind of be my domain there, where I have continuity. So between negative infinity and 2, my graph is continuous. I don't pick up my pin at all, right? And then from 2 to infinity, but there's a hole here, so that's why I have to do a bracket. Oops. Okay, then we're explaining the transformation applied to this y equals x squared, this parent function. So the negative in front reflects it. About reflects. So reflection about x-axis. Okay, that negative in front, that's what that does. Inside, it's the opposite, and it goes left to right. So the opposite of -2 is +2. So it's going to move right 2. And then adding 1 at the end, that is going to move up 1. Okay, that square part just tells you it's a quadratic. Okay, so those are the 3 things that it's going to do. Is symmetric. So how you test symmetry is if you plug in a number for an a for x, okay, and you solve it, and we're going to see if that equals. We're going to plug in a negative a. Or let's not do a. Let's just plug in a number. That'd be easier. Okay, so we plug in a number, say 1. Okay, and I solve this. So 1 squared is 1 plus 3 is 4. So we get 4. Okay, and then I'm going to plug in a -1 and see what I get. Okay, so I still get 1. 1 plus 3 is 4. So I still get 4. So because I got this point 1 comma 4, and then I did the opposite of that, and I got the same answer, that means it's symmetric about the y-axis. So symmetric about y-axis. Okay, if I plugged in a number like 1 and I got 2 answers out, that would be the x-axis. About the origin means that when I plug in 1 I got 4, I would plug in -1 and get a -4. That would be about the origin. Alright, here you're asked to add, subtract, divide, multiply, and find the composition of 2 different functions. So here I'm adding the 2 functions, so I'm going to take x squared plus 3x, and I'm going to add 2x minus 1. This one's the easiest one. So f plus g of x, I'm adding them, equals x squared plus 5x minus 1. When I'm subtracting, I got to distribute that negative to this second equation, so I got to distribute the negative there. So this is x squared plus 3x minus a 2x minus a -1, which is a +1. So I got to distribute that negative. So then I get f minus g of x is equal to x squared plus x plus 1. Usually mess up on distributing that negative. Dividing, we want to go ahead and state the domain. So we go ahead and set our g of x to 0. So g of x cannot be 0 because we can't divide by 0. So we're going to go ahead and take 2x minus 1 and set it equal to 0. Add 1, 2x equals 1, divided by 2. So x cannot be 1/2. So x cannot be 1/2, so then our domain is from -infinity up until 1/2, but it can't be 1/2. And then from 1/2 which it can be 1/2 to positive infinity. So there's our domain. Now we go ahead and, so that's one answer. And that's one of our answers. And then we go ahead and divide them. So we have f of x is on top, so I put that equation on top over the bottom equation. So what I try to do is see if I can simplify. So I can factor out of the top an x, but that doesn't cancel with anything on the bottom. I can't cancel those x's because this 2x is not being multiplied by -1. So I can't cancel that x. So I could leave it as the original, or I can leave it as that one. That's fine. So I can't divide this. Okay, so I would just leave it as that. Okay, multiplying, so I multiply them. So make sure that you're taking 2 terms times 2 terms, so you should get 4. So this is 2x cubed minus x squared plus 6x squared minus 3x. So f times solid dot here, g of x. This one was f of x divided by g of x equals. This one is 2x cubed plus 5x squared minus 3x. So that would be the answer for that one. Okay, and then here f of g of x. Probably should be able to see around there. That means that I'm taking g and plugging it into f. Okay, so I'm going to take the g equation, 2x minus 1, and every spot that was an x in f, it's going to be 2x minus 1 instead. So this is x squared. F is x squared first, so this is now my x, and it's being squared. And then I'm going to add 3 times my x, so my x is now my g, which is 2x minus 1. So I'm going to simplify this to 4x squared minus 4x plus 1, and then plus 6, because I'm distributing the 3. So 6x minus 3. And so f of g of x is equal to a 4x squared, a plus 2x, and a minus 2. So there's all of chapter 2. Okay, so starting in chapter 3, we're asked to graph this. So it's a normal squared function, right? So the vertex, this is in vertex form, so I take the opposite of this, so -2. And then this stays the same, -1. So there's my vertex. So my vertex is -2, -1. That negative's going to flip it, so it's going to face down. So now I could just plug in 0. I could plug in any point. So I just find a couple points, right? So plug in 0. 0 plus 2 is 2. 2 squared is 4. Times the negative is -4 minus 1 is -5. So I get 0 and -5. So I can plot that. 2, 3, 4, 5. Okay. And now I can just reflect that because it's symmetric about the y-axis, right? So, but now it's not about the y-axis. It's about this axis of symmetry. So axis of symmetry, that's what it means by axis. Axis means axis of symmetry. Axis of symmetry. Okay, so that is x equals your x value vertex, so that x equals -2. So it's symmetric about that line, that vertical line right there. So this point down here at 0, -5 is the same distance as the third point. So it is 2 away from this line, so I go 2 on the other side, and I have that same y value. So then I can graph that way. Again, you can always start plotting points. Once you have your vertex, you can plot any points. X equals 0, then you can plug that in. Okay. Where is it increasing and decreasing? Okay, so I draw it from left to right, so I'm start drawing it up. So from on my axis from -infinity, it's increasing all the way to this x value of -2. Okay, and then it's decreasing from there. I'm drawing it down, so it's decreasing from -2 to positive infinity. So my domain is from negative infinity to negative or positive infinity. And my range is my y values. So it's facing down, so that means it goes from bottom to top. So it's negative infinity is my lowest y value, up to my highest y value, which is -1. And that was my y value of my vertex. And it does hit -1, so I do a bracket there. So all quadratics and polynomials, the domain is negative infinity, positive infinity. With quadratics, your range has to do with your vertex, the y value of your vertex. If it faces down, then it's from negative infinity up until that y value, and if it faces up, it's from that y value to positive infinity. Alright, so dividing. So here, and when we get into rational functions, if I was asked to graph this, whenever the numerator is bigger, you actually have to do long division. You have to divide this by long division to find your oblique asymptote. So we could do this by long division, or we can do it synthetic division. We can do it synthetic because this bottom has a degree of 1. So we can do it synthetic division. So you list your coefficients 3, and we're missing an x squared, so we got to put a 0 in there. Then we have our x, -4, and then we have our constant. All right, and we put a 0 in that second row, first column. We add those, we get 3, and then we multiply it by not this number in here. We set that equal to 0, so x equals 2. So 2 is what's going to go in this box here. And we multiply, we get 6. We add those, we get 6. We get 12. We get 8. Okay, so we get 8. 8 times 2 is 16, so we get 19. So here is my new coefficients of my answer to this problem. So since I'm taking x cubed and dividing by x, this answer is an x squared. So this is 3x squared, and then I drop it down. So I go x squared to x, and then I go to my constant, and then I add. Don't forget to add your remainder. My remainder is 19 over what I'm dividing by, and I'm not dividing by 2, I'm dividing by x minus 2. Okay, so that would be my answer to this division problem. So there's synthetic division, there's your answer. So like I said, if you're graphing this, here you wouldn't have, if you are graphing this and the numerator is bigger, then you have to do long division. But if this was a squared instead, then you would do long division and figure out what that horizontal, the horizontal asymptote would be an oblique asymptote. So what you do there is just you would do long division. Whatever your answer is, that would be your oblique asymptote. Actually, if that was a 2, you could actually do synthetic division. And so if it was squared and that was an x, then you would have an oblique asymptote if you're asked to graph this. And this answer would be 3x, 3x plus 2 with the remainder of 7. Well, this 3x plus 2, that would be your oblique asymptote, y equals 3x plus 2. So that's whenever your numerator, if your numerator is bigger, then you could do synthetic division and whatever your answer is, or you could do long division, whatever your answer is. If it's a linear answer, then you would have an oblique asymptote. But since this is cubed, that means our answer would be an x squared, so I wouldn't have a oblique asymptote. Alright, sidetrack, sorry. Alright, use synthetic division. So we have 3, -2, 4, and -1. They're all in order. I have a cubic, so I have four numbers there, and I'm plugging in 2 because this is x equals 2. Right? This is not a factor. Right? X minus 2 is a factor on the top one. That's what I'm dividing by, is x minus 2. Right? This is just plugging in 2. So I plug in 2. So I get 3, 6, 4, 8, 12, 24, 23. So the answer to this, I want to find out what f of 2 is. F of 2 equals my remainder, 23. So there's my answer. Okay, possible rational solutions. So we're going to list the factors of our constant. So that is 1 and 2. And I'm going to list my factors of my lead coefficient, which is 1, 2, 3, and 6. And I'm going to take every single one of these and divide by every one of those. So I'm going to take 1 divided by 1, 1 divided by 2, 1 divided by 3, 1 divided by 6, and they're all plus and minus. So 1 over 1 is 1. 1 over 2 is 1/2. 1/3, 1/6. And then I'm going to take 2 and divide it by all of those. So that's 2 over 1, which is 2. 2 over 2, which is 1. So I already have it, but I'll just list it anyway so you can see. 2 over 3, which is 2/3. And then 2 over 6, which is 1/3, same as the other one. So those are all my possibilities. Okay, and if they're repeating, you don't have to write them twice. Actual ones, that's when I'm going to list synthetic division. And I have to find actual roots, so that's all of them, not just rational ones. So I have to do quadratic formula if I can't factor here. -12, -3, -2. They're all listed 4, 3, 2, 1, 0. And I go through and I start trying to find them. So we can always try 1 first. One's not going to work. So then I can go through my possibilities. I could try -1 and see if that works. And then probably jump down to 2 because it's whole numbers before I start doing fractions. So it really feels nice when you go through and you don't find anything. And then you come back and realize, hey, that was a +2 right here. So that means this is a +2, not a -2, so 1 would actually work. Instead of going through all your fractions, I didn't go through all of them, but I went through quite a bit. What? Okay, maybe 1 won't work, I don't know. 0. Let's, I think 1/2 will work. -1/2 will work. So make sure you have your signs right. Let's go through this. Alright, so let's run through 1 again. 1, 6, 13, 13, 1, 1, -2, -2, and 0. So 1 did work. So x equals 1 is a solution. Okay, and now I can continue on. I kind of need more room here, but that's okay. I'll just put a 0 right here. And I can try 1 again. Maybe 1 will work in, but it's probably not. I think 1/2 will work, though. Or maybe even -2. -2 might work. So 6 again. That's -12, so that's 1. So that's -2, so that's -1. So that's +2, so that's 0. So -2 works. Alright, awesome. Now that I found 2, I went from quadratic, or quartic 4 to quadratic now. So here's my A, here's my B, here's my C. So now I can cab it, if I can. What are the factors of -6 that add up to 1? So that'd be a +3 and a -2. Those are my factors. So I take the opposite of those. So that would be x equals -3 and x equals 2. But I need to divide them by my A, which is 6. So I get -1/2, which I thought I might have found, but then I was wrong because I had a -2 as my constant when it's +2, and then 1/3. So x equals -1/2 and x equals 1/3. So those are all my answers. Awesome. Okay. Now possibles. So that's positives, negatives, and imaginary to get to your total. So my total is 4. So I count the number of sign changes. Okay, so my signs, they're positive, positive, negative, negative, positive. So I count the sign changes. No. Yes, there's a sign change, so that's 1. No. And yes, because that's a positive. Why did I put 2? Jeez, that's positive. So yes, so there's 2 sign changes. So that means I have possibility of 2 or 0 positives. And now I plug in a -1 and see what happens. So I have a negative to the 4th is positive. Positive times 6 is positive. A negative cubed is negative. Negative times a +7 is negative. And negative squared is positive. Positive times a negative is a negative. And then I have negative times a -3 is a positive. And then I have a +2 at the end. So now I count my sign changes here. That's a yes. That's a no. That's a yes. That's a no. So I have 2. So that means I can have 2, or so I could have 2, which for that scenario I could have 2 positives and 2 negatives. That means I have 0 imaginary. And then my other possibility of positives was 0, so I could also keep the 2 negatives, and that means I need 2 imaginary to fill my total. And then, so that takes care of my possible positives. Now the negatives, I have 2, or I have 0, right? So that 0 could be here, and 2 positives, and then 2 imaginary, gets me my total of 4, and I need one more row, because then I could have another 0 for my negatives, because it drops down by 2, right? Because I had 2 sign changes, so that means I go 2 and then 0. And then my positives could also be at 0, and that means I need 4 imaginary to get my total of 4. Okay, so basically I had 2 sign changes here, so that means it goes from 2 to 0, so that's 2 different changes there, or 2 different possibilities for positives. And then my possibilities for negatives are 2 and then 0, so that's another 2 possibilities. So I times those possibilities, I have 4, so that means I should have 4 total rows, which I do. Okay, so those are all my different Descartes' rule of signs. Determine the number of positive, negatives, and imaginary solutions. Now I'm writing a polynomial, so here are my roots, or zeros, or x-intercepts. So I'm going to write, those are my solutions, so I need to write them all. So x equals 3, x equals negative 2, x equals I, and because I have an imaginary, that means its conjugate is also a solution, so that would be negative I. Or if it's a rational, so if it was square root 3 is a solution, then negative square root 3 would be a solution as well. So those are my solutions, or my roots, or my zeros. Now I write my factors. Okay, so my factors are x minus 3, x plus 2, x minus I, and x plus I. Now I want to multiply. And I can start with my conjugates because I can just do first times first and last times last, so x times x. Or maybe what looks like conjugates, even they're not, but these are conjugates. So I get x squared minus I squared, which is actually x squared plus 1, because I squared is negative 1, negative 1 times negative is positive. Then I can multiply these, so I get x squared minus x minus 6. So that's x squared minus x minus 6, and now I'm going to multiply that by x plus 1. And so I get f of x equals, multiply these, so I have a 3 times 2, so I should get 6 terms. So I get x to the 4th, I get plus x squared minus x cubed minus x minus 6x squared minus 6. So I have 6 terms there, as you can see. Combine like terms, so I get x to the 4th, x to the 4th minus x cubed. I got an x squared and a negative 6x squared, so that's negative 5x squared, and negative x and a negative 6. So there's my function. Normally we'd put an a out in front of this, right? And then we might have to solve for that a. If I was given a point, say, and it wrote these zeros, and then it said, okay, f of 2 equals 5. Then I would plug in 2 in for my x's, all my x's, and plug in 5 in for this f of x right here, because that's my y value. So I'd plug 5 here, and I'd plug in 2, and then I'd solve for a. But here, we're not given an extra point, so my a is just 1. So I can write it just like that. Okay, so determine the end behavior. So we want to look at, we can do 2 different things. We can look at the degree, so that's 5, so it normally should look like this, right? Now because this negative out front, that's going to flip it over the x-axis, so our answer is actually going to be, that's our end behavior. So farther out to the left, it goes up, and then farther out to the right, it goes down. Okay, so there's our end behavior. We could just plug in really, really big negatives. So a really big negative cubed, or to the 5th. All this is really not going to matter, right? So a negative to the 5th is negative, but times by negative 3 is actually going to be positive, so that's why I'm going up to the left. And if I plug in a really big positive number, a positive to the 5th is going to stay positive, and a positive times a negative 3 is going to be negative. So that means to the left I'm going to go down, or sorry, to the right I'm going to go down, and to the left I'm going to go up. So that's why my end behavior is like that. Okay, I didn't actually do a graphing polynomial, so let's actually do a graphing polynomial. Let's go back to the ones. So when you're asked to graph something like this, you want to find the zeros, okay? Kind of like what we did back here on this page when we find the zeros here, this list of zeros. So for number 4, we could graph that polynomial. So let's go ahead and just do that real quick. Okay, so at 1, I have a 0. At -2, I have another root. At -1/2, so here, at 1/2, I have a solution, and at 1/3, I have another solution, another x-intercept. So then on my graph, I can graph this by testing points in between and to the left, or I can look at my end behavior, right? So it's to the 4th, so, and it's a positive 6, so that means it's going to go up and up. So that'd be the end behavior. And then since I don't have any multiplicity here, I know I go down, I go through each one of these, each one of those I go through. So I go through each one of them. And I don't really care for now how far you go down. So I could plug in like -1 and see how far it goes down. So I can plug -1 into synthetic division and see what I get as a remainder, and then go ahead and, if it's positive, then I would be above. If it's negative, it's going to be below. This one is going to be below. And I could plug in a 0. A 0, I get 2, so that's why my graph is above, because I get a positive. So that's why it's above here. But you can just use your multiplicity if you know how to do that. If not, you could plug in numbers into synthetic division in between here. So I could plug in a -3 in the synthetic division and see what I get as a remainder. And if it's positive, I draw up. If it's negative, I draw below the x-axis. So there's what this graph would look like if I was to graph. So let's just go number 4. That's what this one would look like. All right. Okay, graphing a rational function. We can go ahead and see if we can factor this, which we can't, so that's fine. We set our denominator equal to 0, so we get x equals 4. And then if we plug that back into the top, we see that we get 9. So it's nothing's going to cancel here, right? We have no like factor, so this is a vertical asymptote. So that's a vertical asymptote at x equals 4. 1, 2, 3, 4. So a vertical asymptote right here. Okay. Now I want the horizontal asymptote. I look at my degree of the numerator, degree of the denominator. It is the same. So then I just divide my lead coefficients. So that's 2/1. So my horizontal asymptote is y equals 2/1, which is 2. So I go up 2 in my horizontal asymptote. So this is y equals 2. This is x equals 4. Now I can just plot points, right? Because I want to approach these vertical well, actually, let's test to see if we get 2. So if I plug in 2 for my f of x, so 2 equals 2x plus 1 over x minus 4. Multiply by both sides by the denominator. Distribute the 2, so I get 2x minus 8 equals 2x plus 1. And now I solve for x to see if it crosses my horizontal asymptote. Notice that my x's are exact same, so they're gone. So I get -8 equals 1. So it doesn't cross the horizontal asymptote. Okay, because I didn't get an x equals something. So I know it's not going to cross that. And now I can just start plotting points, right? I can start plugging in numbers. So I could plug in 0. I could see what I get. I get 1 over -4, so I get -1/4. So a -1/4 maybe right here. And that's really all I need, because I know I'm going to go, I can't go up, because I'm not going to I can't go through that line because I already tested it doesn't cross, right? So that means I'm going to go this way, okay? Because I can't go up from here, because then I would start crossing those lines, right? So I'm just going to approach my horizontal asymptote, and then I'm going to approach my vertical asymptote. If you want to plug in more points, like you could plug in 2, you could plug in 1 and see what you get. But really all I need is 1. Okay? In between each vertical asymptote, you need 1 or 2 points. 1 could do it. Is enough, usually. But if you need more, then plot more. Okay? And now I'm going to go to the right. So I'm going to, how about 5? I want to plug in 5. So I get 10, so I get 11. 11 over 1, so I get 11. So it's way up here. So that means it's going to approach the vertical asymptote. Maybe I should just graph it down here. Let's just say it's down here. I'm going to approach that vertical asymptote, and then I'm going to approach the horizontal. Okay, so there's my graph. Okay, so the domain is everything but 4, right? So it's going to go from negative infinity up until 4, and not including 4, and then after 4. Okay, so there's my domain. My range is all my y values. Now this graph goes down, so it goes from negative infinity, and it goes up, 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 and it doesn't touch 2, right? So it goes up until 2, and then it goes after 2. It continues up after 2. So after 2 goes up. So there's my range. Where is it increasing? So I draw from left to right. Left to right, this is going down, right? So I'm drawing it down. So I'm decreasing from negative infinity up until 4, right? And then I stop graphing at 4. So this is decreasing. And then from left to right, I'm going from left to right. So left, I draw left to right. I'm still drawing down. So after that, 4, I'm still drawing down. So it's not increasing, it's all decreasing. Alright, so the last part of chapter 3, variation problems. So whatever comes before the word varies is what is equal to k. So y varies, so that y equals k. Inversely means divided by, so I'm going to divide that. What follows that is x, so that's what I'm dividing by, x. And now I go ahead and plug in what they give me. They say y is 10, and I'm going to solve for my k, so k is 30. And then I'm going to go ahead and plug that in for my k, leave my x and leave my y, and now I can use this formula to solve for any y given any x. So now they say, okay, what is y when x is 20? So that's 3/2. Okay, what comes before the word varies? R does, so r equals k. And directly means multiplication, just like jointly means multiplication. And the square of m, so that means times that by m squared. And then inversely, so that means now I'm dividing by. Directly means multiplication. Inversely means divided by. So now I'm dividing that by s. And now I'm going to plug in my r. I'm going to plug it, k is always in there. Plug in my m, and that's being squared, so I need to square that. Square the 6, and then over s. So I get 36 over 4, which is 9. Which is 9. 9 times k is 12. So then, divide by 9. So I get 4/3. So k is equal to 4/3. There's my k, 4/3. And now I can plug that in. R equals 4/3 times m squared over s. I could put that 3 on the bottom with the s if I wanted to. But that's okay. Now I'm going to plug in new m, which is 6 again. And 20, I don't know why I put, well, that's fine. M is 6. That's okay. So 36. And my s is now 20, and I'm finding r. So 4/3 times 36, so I cancel 36 and the 3. And so that would be 4 times 12 over 20. And 4 times 12 is 48, so I have 48 over 20. And so there's my r, 48 over 20. And if you want to, you can go ahead and reduce that by, what, 4. So we get 5 plus 12/5. So there's the answer, 12/5. Alright, so that is the semester review. So that is chapters 1 through 3. Yep, so that is all of them. So congratulations, you made it through it.